Welcome back to the channel. Adventures through climate change with your host Trevor Snyder. That is me, where we take an armchair approach. We don't leave my office. We just watch other people's videos that we appreciate them for making. So we always make sure we subscribe and like them, and we kind of diagnose what's going on, what's happening with climate change. We're taking all sorts of an approach, like not just, I say adventures through climate change because I think there's so many things. These videos range from conspiracy theories to hard evidence. So I think that we put this all together and we figure out what the heck's going on. So today is, I think Peter M sent me this one, and we're back on the Milankovitch cycle. I think it's been 2-3 weeks since we touched this. Obviously, we did find from Mr. Ellis that there's got to be other things added to the Milankovitch. It doesn't stand on its own. The tilt is always changing. There's always stuff going on. But let's take a look at this one, see what they have to say, and start from there. Most of these Milankovitch is like it's the end of the world, so let's see if it's the end of the world.
Game of Thrones fans know winter is coming. While the cold season in our latitudes always lasts 3 months, the inhabitants of the fictional kingdom of Westeros are confronted with years of cold and impenetrable darkness. Fortunately, we only find such extreme weather periods in the fantasy world. Or maybe not. Well, not really. In fact, our blue home planet also goes through regular cycles that are reflected in drastic changes in the climate.
That's true.
You would like to know what the background and consequences of these events are all about, and whether we are also threatened with a harsh Game of Thrones winter? Then leave us a like and subscription, and be sure to watch our video to the end to hear all the crazy events that may await us in the future.
I got to make sure to subscribe. I didn't see. We got to take a look at who it was.
At the beginning of our video, it makes sense to first answer a simple question. What actually causes the seasons of the year that we are familiar with? The basic answer is, the seasons depend on how long and at what angle the sun's rays hit our globe during the day. Since the Earth's axis is tilted and our home planet orbits the sun, the angle of incidence of the sun's rays also changes over the course of the year. The basic rule applies here. The more acute the angle of incidence, the fewer sunbeams can warm up the Earth, and vice versa. The steeper our parent star appears to be in the sky, the warmer it gets on the planet's surface. But of course, this pattern cannot be transferred to the entire Earth at the same time. Due to the tilt of the Earth, the seasons are exactly opposite in the two hemispheres. While in most countries, we can't get out of the shivering from December to February, Australians are confronted with the hottest days of the year during this time. But the same applies to the seasons. Exceptions prove the rule. For example, the tropics near the equator are characterized by a diurnal climate, meaning that the angle of incidence of the sun's rays remains the same for most of the year. Strong temperature fluctuations are therefore not registered there seasonally, but only between day and night. The different times of day as we know them are also alien to the inhabitants of the equatorial tropics. The poles also deviate drastically from the usual seasonal pattern. Accordingly, these regions follow an alternation of polar night and polar day, with the sun neither rising nor setting for 6 months. But did you know that the tilt of the Earth's axis is not static, and it is by no means the only factor that determines how warm or cold it gets on our home planet? Let's just take a look at the well-known models of our planetary system. In the corresponding representations, we see how the individual celestial bodies rotate in perfect orbits around our central host star due to the gravitational pull of the sun. However, this representation does not reflect the actual reality. In truth, the sun is by no means the only gravitational force that determines the path of the Earth through space. Although our central star undoubtedly has the greatest influence on us, we must not ignore our planetary neighbors. Above all, the mighty gas giants, Jupiter and Saturn, should be mentioned here. Of course, this scheme can also be applied in the opposite case. Ultimately, the dance of the planets results from the central influence of the sun. and a constant interplay of tugging and pushing of the other bodies. The Serbian mathematician Milutin discovered the effects associated with the resulting changes in the 1920s, and his research changed the way we view our modern world when he discovered the Milankovitch cycles.
I like how this is
Milankovitch cycles are
broken
those
down like
periods
this.
in which the intensity of solar radiation deviates beyond the annual fluctuation range. In detail, the radiation is reduced by 5 to 10% as part of these cycles, which means that they are considered to be the key precursors to the cold and warm periods of the last 3.5 million years. The Earth's orbit, the axis of rotation, the inclination of the axis, and the so-called precession are subject to different time scales, which are accompanied by a noticeable change in the angle of incidence of the solar radiation. So let's get an overview of the individual factors of the cycles. First, there would be Earth orbit. Over a period of 100,000 years, the orbit becomes first more and then less elliptical. It is in the nature of things that the more the orbit resembles a circle, the more constant the distance between the Earth and the Sun remains. Consequently, the fluctuations increase as the shape of the orbit approaches an ellipse. Due to the current shape of the orbit, perihelion, i.e. the point on Earth closest to the Sun, is dated on January the 2nd. The aphelion, the point furthest from the Sun, is again reached at the beginning of July, and although the current orbit resembles more of a circle than an ellipse, we still experience a 7% difference in the amount of sunlight between these two extreme points. As it approaches an ellipse, the value will even level off at up to 23% in the future. The change in axis tilt is again subject to a period of about 41,000 years, with a change in inclination between 22.1 degrees and 24.5 degrees. The angle at which the Sun
Possibly
orbits
more.
the Earth is also subject to periodic fluctuations at higher latitudes. The greater the tilt, the colder the winters are at the higher latitudes, with the summers being warmer in the same breath. While the North Pole of the sky is currently aligned roughly in the direction of the pole star, this will
Oh, man, they did good with this video.
change in the future as the axis tilt changes. It follows that in about 13,000 years, the northern hemisphere will have its summer in January, while the hot season in the southern hemisphere will arrive in June. At the time, Milankovitch assumed that the change in solar radiation embodies a natural pace setter for the various cold periods. In detail, this is due to the growth and melting of large ice sheets. While we still don't fully understand exactly how ice ages come and go, it is clear that some of these frigid periods have conspicuously overlapped with the 100,000-year Milankovitch cycles. According to this, for example, there's a phase in which the plane in which the Earth rotates around the Sun inclines more and more. Of course, the mere change in the inclination of the Earth's orbit does not explain why it then becomes colder or warmer. After all, the distance between the two celestial bodies remains the same. However, this inclined cycle is perfectly consistent with periods when the ice ages occurred over the past 800,000 years. As a result, scientists assume that there must be a direct connection in this regard. Some of the sunlight may be blocked by cosmic dust lying in the plane of Earth's orbit during this time.
Talking about albedo and how
According to
that
current
happens.
forecasts, the occurrence of the next cold period is as certain as amen in the church. In contrast to other climate drives, the analysis of astronomical orbital parameters allows a reliable forecast over several thousand years. Our blue home planet is currently preparing for gradual cooling. Interestingly, however, it is not the colder winters that are fueling this development, but the milder summers, which, on closer inspection, only seems logical. While the snow and ice masses that accumulate on mountaintops and in cold polar regions during the winter months tend to melt away in the summer, a cooler summer can prevent this. Once snow has become a permanent feature of the landscape, enhanced albedo comes into play. This refers to the reflectivity of a surface, or in other words, the more parts of the Earth are covered by brilliant white snow and ice, the more sunlight is reflected back into space. This, in turn, causes surface temperatures on Earth to drop even further, literally fueling a snowball effect. To put it colloquially, we are currently in an interglacial period, but let us not be fooled by this fleeting moment of warmth. However, it remains to be seen how the next cold period will be reflected in reality. In detail, an eccentricity maximum occurs about every 405,000 years, which will mean that the next ice age is likely to be significantly less dramatic than the four previous ones.
I just wanted to add, as we saw in Mr. Ellis's video like a month or two ago, and you guys should go back and check those ones out. What they're finding, or at least what Mr. Ellis alludes to and points to, is when there's so much ice and it kills off, all those all the plant life, and up north and down bottom, and it becomes very arid. And at first that albedo, it's just reflecting all the light. You need the earth, the different colors, to accept the light into it, to warm it. And what happens is it becomes so arid that the dust gets kicked up, into the sky, ends up landing on top of the ice. That's how we get those like glaciers on top of the mountains up in Glacier National Park and Montana and whatnot. I know a lot of the glaciers that were up in the Seattle area are starting to melt off, but they're up in Vancouver and British Columbia and whatnot, and they're different parts of the world. But you get dirt on top of those, and that's the foundation is ice, in essence, and that's how you reduce the albedo, or reduce the reflection to accept more light into the earth to actually warm it up. So, I mean, that's what he was talking about, that goes in addition with the Milankovitch cycle, which makes sense to get us out. The other way is, as we saw, or what they're finding nowadays, or what we've taken a look at, is 11,800 years ago, or whatever they say that they're thinking was huge meteors bombarding the earth to actually warm it and bring it out of the ice age and take us into an interglacial quicker than we would have otherwise. And that's why we're in the current interglacial. So anything could kick us out at any time. But that's just what we've learned from other videos. If you disagree, throw that in the comments. Let's get back to the video. They're doing a great job on this one.
However, it is important to remember that non-astronomical factors also influence the global climate. Let's just think about the changes in the Earth's atmosphere. The changed aerosol and greenhouse gas content could not only interact with each other, but also with astronomical factors. Whether this complex feedback ultimately has a positive or negative impact on our climate remains to be seen. The same applies to the beginning and the course of the next cold period. According to the models and past cycle trends reconstructed using deep-sea sediment cores, we should wrap up and get warm in a few 10,000 years. However, nobody can currently say with absolute certainty whether the calculations will really correspond to reality. This primarily depends on how many man-made and natural greenhouse gases will end up in the Earth's atmosphere in the future.
And how those gases actually affect it, really. I mean,
that may have been a ton of information to throw at you all at once.
It was.
So let's break it down in simpler terms, reflecting on what we just learned before reaching our conclusion. The Milankovitch cycles are a set of 3 astronomical changes that affect the amount of solar energy that reaches the Earth, and as a result, they play a significant role in the Earth's climate change. These cycles include the shape of the Earth's orbit, its eccentricity, the tilt of the Earth's axis with respect to the orbit, its obliquity, and the direction in which the Earth's spin axis points, its precession. The Milankovitch cycles have been considered a robust framework for explaining long-term changes in the Earth's climate, including the ice ages. However, the Milankovitch cycles cannot fully explain the current period of rapid warming that has taken place on Earth in recent years, particularly since the mid-20th century. Scientists are confident that human activities, specifically the emission of carbon dioxide from the burning of fossil fuels, are the primary cause of this warming. The Milankovitch cycles operate on much longer timescales, ranging from tens of thousands to hundreds of thousands of years, whereas the current warming has taken place over decades to centuries. NASA satellite observations have shown that over the last 40 years, solar radiation has actually decreased somewhat, whereas human activities have significantly increased the concentration of carbon dioxide in the atmosphere over the same period. The concentration of carbon dioxide in the atmosphere has increased 47% from 280 parts per million to 412 parts per million since the beginning of the Industrial Age. The contribution of Milankovitch cycles to climate change is just one of several factors. During past glacial cycles, changes in the extent of ice sheets and atmospheric carbon dioxide have played critical roles in driving the temperature fluctuations. For example, the extent of ice sheets affects how much of the sun's energy is reflected back into space, thus impacting the Earth's temperature. During the past glacial cycles, the concentration of carbon dioxide in the atmosphere fluctuated from 100. Scientists are shocked. They have found that
I'm shocked.
your brain cells.
That's
180
true.
parts per million to 280 parts per million as part of the Milankovitch cycle-driven climate changes. Today, however, it is the direct input of carbon dioxide into the atmosphere from human activities that is changing the atmospheric composition. Instruments have found that the carbon dioxide released from burning fossil fuels has a distinct fingerprint that scientists can measure. The Earth's global average temperature has increased by over 1 degree Celsius, 1.8 degrees Fahrenheit, since 1850, and the most recent scientific assessments indicate that the Earth is expected to warm another half a degree Celsius by 2030. These rapid changes in the Earth's climate
Possibly.
due to human activities are in addition to the very slow changes caused by the Milankovitch cycles. Climate models indicate that the Earth's climate is largely influenced by human activities when the concentration of carbon dioxide in the atmosphere exceeds 350 parts per million, and any forcing of the Earth's climate due to the Milankovitch cycles is then overwhelmed. There is no natural change in the balance between the amount of solar radiation absorbed by the Earth and the amount of energy radiated back into space that can explain such a rapid period of global warming. The slight increase in incoming solar radiation over the past century is not a significant factor in the current climate warming. In fact, the warming driven by greenhouse gases from human activities since 1750 is over 50 times greater than the slight extra warming from the sun over the same time period. If the current warming was due to the sun, we would expect to see both the lower atmosphere and the stratosphere warming. But observations from balloons and satellites show that only the surface and lower atmosphere have warmed while the stratosphere has cooled. Finally, Earth is
That's
currently
interesting.
in an interglacial period, which is a milder climate phase between the ice ages. However, this cycle is soon due to change, meaning that life as we know it will be significantly different or may even cease to exist. What do you think about the Milankovitch cycles and the associated consequences for the global climate? As always, let us know your thoughts, suggestions, and feedback on today's video in the comments below. Also, while you're at it, don't forget to give us a thumbs up and subscribe to stay up to date from now on. Finally, please take a look at the other videos of our channel, which we have linked for you here in the credits. And with that, thanks for watching, have a good one, and see you next time.
Yeah, buddy. Man, I thought that was pretty good. Okay, let's take a look. The unknown list. That's what it was. The unknown list. Subscribe, like. I thought he did a great job on the video. I thought the video was very well put together. They explained it. They didn't even say what the 3 things of the Milankovitch cycle was until they got done breaking down what the 3 things were. It was kind of funny. Yeah, pretty much I agree with a lot of that stuff. And I think, interglacial periods are far shorter typically anyways than glacial periods and ice ages. That's probably for sure. And you got to wonder when you got weight on the poles and everything's affected gravitationally, when things dissipate, the weight dissipates from those poles. Is it really being held into place or anything? Like, what is it about the tilt and about the poles, like how the Earth is structured? What is it about that keeps us in there, and what puts us into that other tilt? And you know, I've heard a lot recently about polar shifts, and it's probably the stuff I watch on YouTube. Like, but it's just we'll watch some of that stuff. But like claims that it was supposed to happen in the year 2000 and we're due anytime. But it's just this type of stuff is interesting because uh, obviously when you melt something, I know. If anything, like when you're throwing things around, if you shift the weight that's on the end, it's gonna shift how the thing rotates. So yeah, that's all I'm saying. That's all I'm saying about that. If I earned your subscription, I would love if you hit that, hit the like. More importantly, lay down a comment. If you got something to say to me, point me in the right direction. I think this was Peter's video that he suggested to me, and I think we should keep going to the Milankovitch cycle every 2-3 weeks because then somebody else's video, and I like ones that are made. This one was made 8 days ago. Because then it gives somebody else's perspective and way of telling it, and maybe it hits home for you on a different way. With that being said, I will catch you on the next video.